Have you ever wondered what makes seawater salty or how table salt ends up in your food? In chemistry, salts are the result of a reaction between an acid and a base, typically called a neutralization reaction. A salt is made up of two parts, a cation, which comes from the base, and an anion, which comes from the acid. Some salts dissolve easily in water, while others don't, and this depends on their ionic structure. You'll find salts naturally in seawater, mineral deposits, and even in our bodies, and they're also produced in huge amounts in industry. From kitchen shelves to science labs, salts show up everywhere, but what are they really like? Most salts are crystalline solids with high melting and boiling points due to strong ionic bonds. In molten form or dissolved in water, salts conduct electricity because of the presence of free-moving ions. Some salts are colorful, like blue copper sulfate or orange potassium dichromate, due to the metal ions they contain. While sodium chloride is salty to taste, other salts may be bitter, tasteless, or even inedible. Not all salts are created equal. Their composition tells us a lot about how they were formed. Normal salts are formed by complete neutralization, like sodium chloride or potassium sulfate. Acid salts result when only some hydrogen ions in a polybasic acid are replaced. An example is sodium hydrogen sulfate. Basic salts are created when a polyacidic base is only partially neutralized, such as bismuth oxychloride. Each type reflects a different balance between acidic and basic components. Ever thought about how salty substances can be acidic or basic too? It all depends on pH. Neutral salts, like sodium chloride, do not hydrolyze and have a pH around 7. Acidic salts, such as ammonium chloride, give a pH below 7 when dissolved in water. Basic salts, like sodium carbonate, produce a solution with a pH above 7. The final pH of a salt solution depends on the strengths of the acid and base from which the salt is formed. Did you know your food preservative and your laundry detergent might both be salts, just from different origins? Organic salts contain carbon-based ions, such as sodium acetate, commonly used in food preservation. Inorganic salts come from mineral acids and are widely used, like sodium sulfate in detergents or agriculture. Understanding the origin of a salt helps us predict its behavior, solubility, and applications in real life. Salt classification isn't just for textbooks, it's a tool for smarter chemistry. By knowing the type of salt, we can predict reactivity, identify applications, and ensure safe handling in labs and industries. It also plays a key role in assessing the environmental impact of large-scale salt use, from road de-icing in winter to soil treatment in agriculture. In short, salt classification helps us use these essential compounds responsibly and effectively. Let's summarize what we've learned about salts. Salts are ionic compounds formed through neutralization, a reaction between an acid and a base. They are typically recognized by their crystalline shape, high melting points, and ability to conduct electricity when molten or dissolved in water. Salts can be classified in many ways: by their composition, such as normal, acid, or basic salts; by pH behavior, like acidic, basic, or neutral salts; or by origin, whether organic or inorganic. Each type of salt has its own set of properties and uses, from industry and agriculture to medicine and household applications. Understanding how salts are classified not only helps us predict their reactivity, but also ensures safe usage and evaluation of their environmental impact.